Hi, Integrated Math 1. Welcome to lesson 2.3.4b, where we're continuing with systems of linear inequalities. Yay! Back to the warm-up on page 203. We did number 1 last time. We're going to do number 2 this time. If you want to do the others, that's okay too, but we're just going to worry about number 2 right now. So on page M2-203, determine an ordered pair, x and y, that satisfies each inequality. So something you can plug in for x, something you can plug in for y, that would make that inequality true. In this case, x minus y is greater than -7. Hit pause, see what you can come up with, then hit play when you're ready to keep the party going. So lots of possibilities here, right? We just need two numbers that, if you subtract them, would be greater than -7. So how about 5 and 1, right? That'll work. 5 minus 1, that's 4. That's greater than -7. Hooray! I'm going to write it as an ordered pair. So 5 is my x-coordinate, 1 is my y-coordinate. Huzzah and happy day. So nothing too exciting, but this is a solution. You probably pick different numbers. That's okay, as long as when you subtract them, it's greater than -7. It's a solution. Hooray. So lots of possible solutions. These are just the ones I picked. So we're continuing to work with constraints. We're continuing to work with our systems of linear inequalities. We've already established that we often refer to these inequalities as constraints, right? And now we saw last time that we graph them, and it's the bit where it overlaps, right? The section of the graph where they overlap, that's where our solutions are. And that's why they're called constraints, because it's the solutions are constrained to that section of the graph. So again, our learning goals from last time: represent constraints in a problem situation with systems of inequalities. We've been writing and graphing systems of linear inequalities. We graph the solution to a system of linear inequalities in two variables as the intersection of the corresponding half planes, right? Half plane, where they overlap, that intersection, that's our solution. And we've even been verifying solutions to systems of linear inequalities algebraically, right? Pick a point, plug in the numbers. Does it work for both inequalities? If it doesn't work for both inequalities, it's not a solution. Yay. So let's hop on over to page M2-210. And let's pick up where we left off. So Jackson and a group of friends decide to use the fitness room after school. A sign on the wall provides the information shown. Now, this is tiny on my screen, but if you have it in your book, obviously it's bigger and it's easier to read. So, treadmill is a light effort, 7.6 calories burned per minute. Treadmill doing a vigorous effort is 12.4 calories burned per minute. Stair steppers with a light effort is 6.9. Stair steppers with a vigorous effort is 10.4. Stationary bike with minimal effort is 5.5. And a stationary bike with vigorous effort is 11.1. So here's the deal. Jackson decides to use the stair stepper. Okay, so it looks like we're looking at these two in the middle, the stair stepper. He has at most 45 minutes to exercise, and he wants to burn at least 400 calories. See if you can write a system of linear inequalities to represent Jackson's workout. And define your variables. And I'll help, actually, let me help with defining the variables. I'm going to say that X is the number of minutes doing a light effort on the stair stepper. And we'll say that Y is the number of minutes doing a vigorous effort on the stair stepper. So write two inequalities. You should probably write one inequality for the number of minutes and another inequality for the number of calories. That's my hint to you. Go ahead. Hit pause, see if you can write this lovely system of linear inequalities, and then hit play when you're ready to check your work. So, first of all, he has at most 45 minutes to exercise. So, X minutes with a light effort plus Y minutes of a vigorous effort. But he only has 45 minutes at the most. So if he exercises less than 45 minutes, he's okay for time. If he exercises exactly 45 minutes, he's okay for time. But if he goes over that, he's probably going to be like late for work or something like that, right? So I'm going to say that x plus y has to be less than or equal to 45. All right. Again, it might be a work thing. It might be appointments. It might be family obligations. I don't know what he's got going on in his life. Ooh, let's talk about calories, though. So he wants to burn at least 400 calories. Well, we know that the light effort on the stair stepper is 6.9 calories per minute. So we'll say 6.9x. Plus his vigorous effort on the stair stepper, which would be 10.4 calories per minute times y minutes. We don't know how many minutes. And he wants to burn at least 400 calories. So it's okay if he burns exactly 400 calories. It's even okay if he burns more than 400 calories. He just doesn't want to burn less than that, right? So we're going to say that this has to be greater than or equal to 400. That's what we'll say. I'm going to erase this so you can see the pretty version. Look at it all typed in pretty. Ooh. All right. We're going to skip several pages here. We're not going to skip several pages. We're going to skip over to the next page, page M2-211. So now that we have this lovely system of inequalities, I want you to graph it. Yeah, I want you to graph it. You may want to go ahead and solve for y. That might make it easier. If you've got Desmos handy, I won't know the difference. You're online watching this right now. But do notice that our graph, we're only dealing with the positive, which makes sense because there's no such thing as negative minutes. I don't know what negative minutes look like. Go ahead, hit pause. Make sure you label your axes. It'll make things easier. And then hit play when you're ready to check your work. So here's what I did. I know that everything is in minutes, all that good stuff. But I'm going to go ahead and label this. It looks like I'm going to count 5, 10, 15, 20, that kind of a thing on my x-axis. And we're going to say that this is the minutes of light effort, right? X is the minutes of light effort. And Y is my minutes of vigorous effort. I probably should number that as well. Let's do the same, 5, 10, 15, 20 on up. Sweet. Let's go ahead and we will graph these. If you want, you can get the y alone. That's what I typically recommend. So x plus y is less than or equal to 45. Sorry for my pen being weird. I'll subtract x on both sides, and I have y is less than or equal to negative 1x plus 45. We say over 1. So my y-intercept is 45, which is all the way up here. Yeah, that works. My y-intercept is 45, and we go down 1 over 1, down 1 over 1, which means I'm going to end up with a solid line. Pew. Now, it says y is less than all that, so I need to shade below. So I'm going to shade below. Yay. Let's look at the other one. The other one's messier. Ugh, the other one's messier. That's all right. We'll survive it. 6.9x plus 10.4y is greater than or equal to 400. So I'm going to go ahead and subtract my 6.9x on both sides. This is not going to be pretty. 10.4y is greater than or equal to negative 6. I got a little carried away. Negative 6.9x plus 400. Divide by 10.4. Again, not pretty, but we're going to make this work, okay? I'm going to use a calculator. I'm going to try to use a calculator without hurting myself. So I have y is greater than or equal to negative, let's see, 6.9 divided by 10.4. I usually like doing fractions. It's not perfect, but it looks like I get about negative 2/3 x. It's not perfect, but it's pretty close to that. 400 divided by 10.4 gives me about 38.5 approximately. It's not perfect. So my y-intercept is going to be just a little below 40. It's going to be down 2 over 3, that kind of a thing. And, solid line. Whoa, there we go. And we're going to shade, it says y should be greater than or equal to. So I need to shade the half plane above. And look at this. Look at this. We have our little sliver right in here. Whoa. There's the overlap. There it is. All of our solutions are sitting there. So all of our solutions are sitting right in the sliver in the middle. Awesome. So can you identify two different solutions of the system of inequalities? Just pick two solutions in the sliver, people. Hit pause, give me two solutions, hit play when you're ready to keep going. So you may have picked different solutions than I did. That's okay. I picked 1035, like right there. That's a solution, right? It's part of the sliver. Sure. I also picked like 736, like it's like up over here or something like that. That looked like a good point. It's in the sliver. It's in the sliver. You probably picked different numbers. That's okay. That's okay. If you pick different points, as long as they're in our overlapping sliver, we're okay. Can you just interpret what your solutions are, though, that you found? Like, what do those numbers mean in terms of Jackson's workout? Hit pause. Give me your interpretation. Hit play when you're ready to check your work. So I'm going to obviously use the numbers I picked. Again, yours might be a little different. So one of the points I picked was 1035. So that means that Jackson can exercise with light effort for 10 minutes and exercise with vigorous effort for 35 minutes. He'll burn at least 400 calories and in at most, that should be a T there, in at most 45 minutes. I also picked 736. So that means Jackson can exercise with a light effort for 7 minutes, exercise with a vigorous effort for 36 minutes. He'll still burn at least 400 calories in at most 45 minutes. Actually, I think that puts him a little under 45 minutes. So good job, us. Okay. And one last thing, can you take those 2 points that you just found? Again, I'm going to use my points, but use the 2 points that you just found. And can you algebraically prove that your solutions satisfy the system of linear equations? Can you plug your numbers in for x and y and make sure that's less than or equal to 45, that's greater than or equal to 400? Go ahead, hit pause, plug them in and prove it. Hit play when you're ready to check your work. So first point I picked was 1035. So x plus y is less than 45. 10 plus 35, which is 45. Yeah, that's less than or equal to 45. Good job. Let me check the other equation. 6.9 times 10 plus 10.4 times 35. Totally used a calculator here. 6.9 times 10 is 69. 10.4 times 35 is 364. If I add those together, I get 433. And yes, that is greater than or equal to 400. So this is a solution. Let's check the other one that I picked. Again, you probably picked a different one. Use your numbers. So my other solution that I picked was 736. So instead of x plus y, I'll say 7 plus 36. 7 plus 36 is 43, so that is less than or equal to 45. Good job, us. And let's check the other inequality. So 6.9 times 7 plus 10.4 times 36. Again, I used a calculator. 6.9 times 7 is 48.3. 10.4 times 36 is 374.4. When I add those together, I get 422.7. So yeah, that's greater than or equal to 400. Meets our workout requirements. All right. I have for you 4 systems of linear inequalities. Ooh, I would like you to consider all of these systems, system A, B, C, and D. Now, there are definitely some similarities here. 3/5 x plus 3, negative 3/5 x plus 3. They all have that. But notice we have less than, greater than, greater than, greater than, greater than, less than, less than, less than. So Adele made a statement about these systems of linear inequalities, and it's incorrect. Can you explain why? Hit pause, write down why she's wrong, and then hit play when you're ready to check your work. So she said, Adele said, since the equations in each system are the same, the graphs and solutions should all be identical. Well, except that's not true, right? Because which side gets shaded is going to change our solutions, doesn't it? So she is true that the equations would be correct, but that only defines the boundary lines. The combinations of our inequalities are not the same. So the intersections aren't going to be the same. The intersecting regions are going to be different. The solutions will not be identical. So while the boundary lines will be the same, the overlapping sections will not. I would like you to match a graph and possible solutions. So here we have graphs. I have graph A, graph B, graph C, graph D. I also have underneath possible solutions. So possible solutions A, possible solutions B, possible solutions C. And please notice D is blank on both of these. Sorry. I would like you to match the graphs and solutions to each system. And then, of course, complete the blank graph and partial solution set to make the 4 sets complete. Go ahead, hit pause, do a big matching game along with our systems earlier, and then hit play when you're ready to check your work. So first of all, I see that the overlapping section is below both lines. So that to me says I need to pick the system that has y is less than for both of them. So that would be graph A. Oh dear, why did I say graph A? So graph A, I'm going to say, let me come back here. Oh, system D has less than for both of them. So I'm going to say graph A goes with system D. And let's see, 0, -6 is a solution. 4, -4 is a solution. Yeah, so it looks like it also goes with possible solutions A. Sweet. Now I'm looking at graph B over here, and I'm thinking, hello, graph B. I'm thinking it's below the -1. So y is less than on the -1, but it's above the one with the positive slope. So y is greater than the one with the positive slope. So let me come back over here. So y is less than the negative slope, and y is greater than the positive slope. Yeah, I think that's system C. And let's see then, possible solutions. I already used A, so let me check this. We said 0, 7.5. Yeah, that's not a solution. All right. -6, 4. So -6, 4. Yeah, that's a solution, as is -10, 8. Yeah, those are solutions. So we're going to say possible solutions C. Now for graph C, we actually have them flipped. So it looks like y is less than the positive slope and y is greater than my negative slope. So that means if I come back over here, so we said y is less than my positive slope, greater than my negative slope, system A. It's system A. Whoa. So graph C is system A. Which solution set? Probably this one, right? If we have 0, oh no, not that one. 0 and 7.5, that's not a solution either. Or -4, 10. Okay, so it looks like I need to come up with my own solutions, possible solutions D, and you can come up with your own solutions here. I picked a couple. So I picked 5, 3. I was like, there's a solution, yay. I also picked 8, 6. There's a solution, yay. So I got to pick my own solutions for that one. So for graph D, so I've used system D, system C, system A. It looks like we need to graph system B. Well, we know they're going to be dashed lines, so we got to pick system B with this. We know it's going to be possible solution C. Let's graph this thing. We know we have 2 dashed lines, just like the others, same dashed lines as before. Only now, if I have a solution of negatives, pardon me, I can do this. 0, 7.5 is up here. -4, 10 is up here. It looks like this is our shady bit. Yay. So it's interesting because even though they all had the same boundary lines, every single one of them had a different set of solutions, right? Depending on where they ended up on the graph. It's very different. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions, concerns, come talk to me. We can work it out. And I'll see you guys soon. Bye.